Bismillahirrahmanirrahim. Today my topic is data analysis using SPSS. Today we learn different tests. You cannot go back and change the beginning, but you can start where you are and change the ending. Learning outlines of today's presentation is introduction to t-test, one sample t-test, independent sample t-test, the pair t-test, ANOVA, regression analysis, mainly linear regression, and measurement of risk through SPSS. By the end of this presentation, participants will be able to describe the various types of t-test, ANOVA, linear regression, and data analysis process by SPSS. Now come towards t-test. There are few assumptions before performing the t-test in the SPSS. First of all, first assumption is that dependent variables may be interval or ratio in the ratio form, that may be continuous or in quantitative form. The population from which sample are drawn is normally distributed, but if the sample is large, the procedure perform often well for normal distribution. Means if the sample is large, you can perform t-test as well. Samples are randomly selected. The groups have equal variance, means homogeneity of variance. That all observation has equal variance. The independent variable is categorical with two levels and there is no significant outliers. The data or independent variable are not correlated or related, which mean that there is no relationship between the observation or not correlated with each other. Main assumption is dependent variable is interval or ratio and independent variable is categorical with two levels, and these are not correlated and there is homogeneity of variance. These are few assumptions which should be met before performing the t-test. There are basically three t-tests which can we perform. One sample t-test which compare a single sample with a population value. For example, we conduct or compare the average salary of nurses with a company with a value that was known to present the nation average for nurses. For example, we have the sample mean and we compare this sample mean with the population mean which is given in the study, which is one sample t-test. Another type is independent sample t-test, which is used to compare the two group scores on the same variables. For example, you compare the salaries of nurses and physicians to evaluate where there is difference in their salaries. Actually, in independent sample t-test, there is two sample or two groups, and we compare the mean values between these two groups. In paired sample t-test, we can compare the mean of two variables within a single group because the study population is same and we perform the test before and after. It could be used if there is statistically difference between starting salaries or current salaries among the general nurses in organization. The population remain the same and we see the fact before and after in paired sample t-test. For example, performing the one sample t-test. For example, we want to test where the average age of study participant in any study is different from the 45 years age, which is the study population mean age. For this purpose, we perform the one sample t-test. We go to the menu selection of the SPSS and in the file analyze, first we click the analyze menu, then go to the compare means, one sample t-test, and in the dialog box of one sample t-test, this if window is open and any variable, for example age, I want to check the whether the age of study participant is different from population which is 45 years. You enter in the test variable age in years and test value is as it is population is 45, which value which is given is mean is you enter in this test value, and in the option you tick the one sample t-test and okay, click. There is one sample t-test output sheet is open in the open output sheet of the SPSS. In this output sheet there is two tables actually. One table is describe the one sample t-test statistic which describe age in years. Mean is in this, the mean age is 33 years of sample and standard deviation is 9.6. And the second table which open in the window in one sample t-test is indicates the t-value, degree of freedom, and statistically significant value. And in this, the degree of freedom and the statistically significant value one sample t-test, which indicate that as in the this there is zero point zero value, and it indicate that it is statistically significant, and the result of this indicate that the population means are statistically different because because the value is less than 0.05, it means it is statistically significant, and the mean value is different. Sample mean value of the population is different for because sample mean is 33 and the population mean which we test is 45. This is output of one sample t-test if you want to perform. For example, if we want to perform the two groups, or we want to compare the means of two groups, we need the independent sample t-test. For example, there is statistically significant difference in the income level by using the prevalence of psychological distress. In this test value, in this there is one dependent variable which in SPSS is known as test variable, and in this there is income, and the other variable which is the independent variable is the prevalence of psychological distress with two levels, yes or no. Then in this same analyze compare mean in, but in this state or in this condition we take the independent sample t-test. Click the independent sample t-test, then move the test variable or dependent variable in the test variable section. For example, in this case is income, and the grouping variable which is presence of psychological distress, which is yes or no, and there is two categories of presence of psychological distress, yes or no. Independent variable go in the grouping variable, then option you take independent sample t-test, and there is open the two output window. One is the group statistics, which simply describe the income and psychological distress mean and standard deviation. For example, in first column there is the mean and standard deviation of those participants who has a psychological distress, and the second who do not have psychological distress mean. The main output sheet we look in the independent sample t-test is the second column which indicate income, and there is two columns, equal variance assumed and equal variance not assumed. Which column we target and we define the t value is depend on the Levine test of equality of variance in t test, and it is very important to determine in which row we will represent our value of t test. And therefore the independent sample assumed that the variance of dependent sample for both group are equal in population mean there is homogeneity of variance. Therefore this assumption is evaluated with Levine test for equality of variance. Therefore, the probability associated with Levine's test for equality of variance is greater than alpha, indicating then equal variance assumed for the independent sample t-test used for the analysis. It means that if Levine test of equality, for example, f, and its significance value is 0.05 is not significant, mean it is more than greater than alpha, then we assume the equal variance assumed column, and we noted our result or indicate our result or t draw our t value from this, and significant values or also this. But if the significant there is less than alpha value, for example there may be 0.02 0.01 or a significant value, then you can move in the lower row, mean we can indicate the result equal variance not assumed. Equal variance assumed only if there is non-significant result in the first row of Levine test. Therefore, the Levine test is important for indicating the result in independent sample t-test, and it will decide whether we target the equal variance assumed or not equal variance assumed result in output sheet of t-test. Now come the paired sample t-test. The paired sample t-test, we have the two values. For example, we give the we want to check the blood pressure or any pre-score or post-score. We have the readings of pre-score and post-score, and the population is same, but you can perform the results before and after, pre and post test. Therefore you can simple analyze compare means, but in this way you can go to pair sample t-test and then click on the post and post test results, and there come the output of the pair sample t-test, SPSS output, pre-score and In this window, there is also first table is simple descriptive statistic which show the mean and standard deviation, and other is actually the second column which show the pair sample correlation. For example, we want to see whether there is a statistically significant result between pre and post score. As it indicates there is 0.017 result, it means it is statistically significantly associated. And this paired sample t test and first column indicate that the gain in mean score is 14.7 points in pre and post results. Therefore, the result we indicate is the paired sample t-test statistical significance mean score gain from t-score to post-score is t-value minus 18.96 and p-value is less than 0.05. As the researcher is interested in assessing the result in one direction, this is one-tailed test, and the significant value is two-tailed. Therefore, in the table before reporting the p-value, you must divide the two before reporting the result. Therefore, we divide the significance value 0.02 0.00 with 2, and therefore we report the p if we want to determine the two-tailed test. Now come the analysis of variance. The analysis of variance of ANOVA is another test in order to compare the means, but in this there is the statistically significant difference at least three, but in this there is the difference is that our independent variable has the three categories. At least three or more categories, we perform the analysis of variance. Purpose of ANOVA is analysis of variance. It is a collection of statistical model about comparing the mean values of different groups. In SPSS, we can calculate one way ANOVA in different ways. You can also go in analyze, compare means or one way ANOVA, or you can go to analyze general linear model or univariate analysis or linear regression. The main difference in t-test and the ANOVA is that t-test difference between the two groups, whereas ANOVA tests the difference between three or more groups. In the ANOVA, there is further also extension. The ANOVA tells the difference between the two or more groups. But if we want to determine the subcategories, we further move to the extension of ANOVA, which is post hoc analysis. For example, if we use to extend the analysis of measure of difference from one subsection to another subsection, we proceed to post hoc analysis test. Within post hoc test, we have further subcategories in terms of homogeneity or heterogeneity of variance. For example, one way of ANOVA result, first column you is simple descriptive stat, and another output sheet is between groups, which simply tell about mean square is between groups or within groups, and there is statistically significant difference or not. But if we want to determine the statistically significant or mean difference between the categories, we should perform the post hoc analysis in the SPSS, which is known as multivariate analysis within the SPSS. Post hoc test may be many LST to case test, but most commonly you can tick on many which you want to determine. In this way, group 1 and group 2 you can determine by post hoc test the various significant difference between the categories or subcategories of the one way ANOVA. For example, this is the analyze. We can go into the descriptive. We can compare means. There is one way ANOVA. You can perform the. You can want to see the effect of income on the education. In the education, there is our dependent variable go into the income column, and education has many more than two or three categories. It can go to factor column, and for further example, we can go into post hoc test. I also want to perform post hoc analysis to test test. There may be also when Peroni test LST. It depends on you. You can perform through which test. Option descriptive stat. There is also homogeneity of variance and various options, and then okay. The SPSS, there is SPSS sheet in this way gives the various output sheet, In first column there is the descriptive stat of income and education, effect of education on income. There is mean and standard deviation of various categories of income, education, and then there is the difference between the groups and within the groups. ANOVA in this way test of homogeneity of variance, and there is output results of the ANOVA test. Now come towards regression analysis. Regression is actually the prediction of one variable on the basis of other variable or the set of variables. For example, we want to determine the effect of various independent variables on the dependent variables. But before conducting the regression analysis, you should ensure that all variables are continuous. For example, we can predict the effect of blood pressure when the age of person is 55 years. As you indicate that both are quantitative, the mathematical equation should be BP is y actually, and a and b is the coefficient of equation, and age is x. In this, we can perform and go to analyze regression linear and put the dependent and independent variable in the respective box and click OK. Before running the linear regression model, there is few assumptions you should meet. Assumption one is that I already mentioned the two variables should be measured at continuous level. For example, there should be interval ratio, and for example, revision time measured in hours intelligence means both are quantitative and either in the form of interval or ratio scale. Assumption is that there need to be linear relationship between the two variables. To checking the linear relationship, you can plot the scatter plot to Excel, or you can plot through uh, SPSS. Various graphs are generated when there is linear or dots are linear across the line. It indicates the linear relationship, and in this graph there is no linear relationship. Therefore, second assumption should meet. This should be linear relationship. Assumption three is that there should be no significant outliers, and outliers have actually observed data that as dependent variable is very different to value predicted by regression. And in outlier will be pointed on scatter plot that is vertical far away from the regression line. For example, this is regression line and this is observation value, and this value may be outlier because it is deviated from the way from the regression, and this is also the outlier. Therefore, there should not be significant outliers in your value before running the linear regression. Assumption 4 that these value, your value should be independent of observation. They should not be correlated. Fifth assumption is that there should no homoscedasticity. They show homoscedasticity. What is homoscedasticity? It is actually the variance along the line of best fit, similar as you move along the line. To assess the homoscedasticity of your data in your enhanced linear regression guide, you can also perform the scatter plot, which provide the three example. For example, in this scatter plot, this is heterodisasticity because the dots are not aligned in the line of the regression. But in this, as you know, there is homodisasticity, and the data meet this assumption before performing the linear regression. It means that there is homogenesis of variance. Variance are similar across the observation, which is known as homoscedasticity in the linear regression. You can also this check through the scatter plot. Another assumption is that you need to check about the residual error of regression line, or they are approximately normally distributed or not. Means that your variable is normally distributed or not. You can perform or check the normal distribution through two methods. One is either you can perform histogram or plot histogram of your variable with normal curve, or you can plot normal PP plot. Therefore, before performing the linear regression, these six assumptions should be met. First, second assumption, which is known as the there should be linear relationship, which can check through the scatter plot performed first, and then check various assumptions. For example, this is normally distributed. There is homoscedasticity, and normal plot you can check through normal curve or normal PP value. And remember, if you cannot check these assumptions before running the linear regression, you can may get the result, but these results are not valid. In this equation, for example, there is normal. distribution of sample size, and they plot the pp value in order to check the normal probability plot. As you see that this is a normally probability plot of sample, because in all observations are fairly straight across the lines and there are no dots which is scattered across this regression line. And you can also check the histogram. As you see that this is normally distribution and it fairly looks symmetrically and unimodal. But in this plot there is dots which are actually deviated from the regression line, and this is actually see the right skewed, and it look but unimodal and rightly skewed. And in this example there is also ppq plot, but it is not normally distributed and it has s-shaped curve, but somewhat it is normally, it is because the more dots are not away from the regression line. In this histogram plot you see that there is two mode multimodal and it is roughly symmetrical. Therefore, before running the linear regression, you should check all these assumptions before performing. Now analyze, then go regression, then go linear. After meeting all these observations, then you should go on the linear regression. And then in linear regression this window open, dependent variable, independent variable. For example, you should want to determine the effect of income on the price. In your select the price as dependent variable and the independent income as an independent variable. Move in this table, and then statistic. Okay, this output sheet is open in the regression model, which will generate few tables. First table is actually the model summary of a linear regression, and in this indicate r value, which is actually the simple correlation value. And as you see that 0.8 value, which means that it is indicate a high degree of correlation between two quantitative variables, which is actually the price and income, and these are two quantitative. And other is r square. R square is actually indicate the total variation in dependent variable, and adjusted r square is 0.74, and it indicates that there is the price can be explained by the independent variable, that the effect of effect of income on price is 76.2%, which is very large, which is actually explained by the r square, which indicate the effect of independent variable on the dependent variable. R is in the first column, r is correlation, and r square is actually the total variation of dependent fact which we want to measure in the linear regression. This is the first table output. In the next summary, the next table is actually the ANOVA table, which indicate the regression equation fits in the data or not. It predicts the dependent variable. In this, the first model is regression model, and this table indicates the regression model. Sum of squares indicate, and it is degree of freedom, and other is mean square, f value, and significant value, which is p value. And it predicts the dependent variable significantly if it wells or not. How we determine? If we look at the regression row and go to the regression row and go to the significance column, this indicates that the significance statistically significance of regression model was run and p-value is less than 0.05, and it indicates that overall regression model statistically significantly predicts the outcome variable and it is good for the data. Mean it is statistically significant, and it means that your data is fit, or dependent model is good fit for the data, or dependent variable is significantly well predict through independent model. The other table, third table which is generated in the output sheet is coefficient table, which provides with the necessary information to predict price from income as well as determine whether income contributes statistically significant model to model. In this, there is coefficient, and there are two actually coefficient, which is beta coefficient, unstandardized coefficient. It is indicate the b value, and other is the standard error, and therefore we can use value in b column as unstandardized coefficient or beta value, which is determine whether income contributes significantly significant to the model. And if as p value is less than 0.05, therefore it indicates that the it is statistically significant, and it statistically significantly predict the outcome variable, and it is good for the and it actually determine independent variable have effect on the dependent variable. Therefore, these three tables are generated in linear regression. I already mentioned. First table is descriptive stat I indicate, and second is the model summary, which is R square, adjusted R square, and third is ANOVA table, which is regression, and it indicates the sum of square, degree of freedom, mean square, F value statistically significant or not. Therefore, three table is are generated in the output which I describe. In SPSS, if you want to determine the measurement of risk and you have 2 by 2 table, mean if you have in the variable have two options, yes or no, you can also determine the risk through SPSS. How we can determine, for example, exposure and outcome, the odds ratio in calculated in cross tab. You can open analyze descriptive stat and go to cross tab statistic and then click on risk and continue. For example, I want to determine the um, I want to determine the risk ratio between the psychological distress and employment status. In this both variables, I have two categories. Psychological distress has yes or no category. Employment status is also yes, employed or unemployed. Therefore, I move one. After analyze descriptive stat cross tab, I one move this window is open and I move one in the row is psychological distress, other in employment status, and then tick the risk in the statistical section and then OK. This output is open. It is actually the 2 by 2 table, and thus this risk estimate is shown odds ratio for psychological distress as 95% confidence interval, and this is a value of odds ratio which or risk estimation which can you measure through chi-square test or cross tab. But the indication is that your variable should have two categories. If you have three categories, it does not measure the risk ratio. Now come towards the there is time for MCQs. MCQs 1. Mr. Akbar wants to understand whether there is difference in test and anxiety score based on education level by using test and anxiety as dependent variable and education level as independent variable, which has two groups, undergraduate and postgraduate. The most appropriate statistical test should be one-way NOVA, two-way NOVA, independent sample t-test, paired sample t-test, or z-test.
C.
Yes, see, because there is two categories of the independent variable, educational level and independent education. Two groups, undergraduate and postgraduate in independent, and the dependent variable is the test score. They want to determine the test and anxiety score between the groups. Therefore, the correct answer is one independent sample t-test. Paired sample t-test is not because the population is different, and z-test is also not, and one way over two way because it is two groups actually. In MCQs 2, her researcher decided to investigate whether an exercise or weight loss intervention is more effective in lowering the cholesterol level. He has two groups. Group 1 underwent a calorie control diet, and Group 2 is underwent the exercise training program. From SPSS statistic output, researcher uses equal variance assumed formula for independent sample t-test in his analysis. What should be the probability of Levine test be in order to be equal variance assumed row of t-test? It should be significant. It should be significant as less than 0.01. It should be significant as 0.01, or it should be significant p, or it should be non-significant. Means which row of t-test equals variance assumed when the p-value is 0.05.
E.
E.
Not significant.
Yes, a correct answer is E, because if in the first row or Levine test the value is non-significant, you should be kept at you should take the equal variance assumed result, and Levine test probability of Levine test is that you use the t value result significant p value of equal variance assumed row. A researcher wants to determine whether children from divorced parents scored higher in compulsive behavior than other children. He take a random sample from each group separately and then an independent sample t-test. Where would he look on independent sample t-test? SPSS output identify their significant difference.
Please, I would like to add one thing. Dr. Khalsa, I want to add one thing. This is a very good MCQ that you have presented.
Uh, what could he look an independent sample t-test to identify whether there is significant difference between the groups? Descriptive statistic column equal to
Dr. Hansa, could you hear me, please?
yes मैडम अभी आवाज आई है.
Right. These MCQs are very nice, and you have put a lot of effort in making them. In MCQ 1, I want one important thing that has been missed, that you have not mentioned the sample size. Without sample size, it is very difficult to differentiate whether we have to apply Z-test or not. Because we know that when the sample size is less than 30, then both the T distribution and Z distribution both coincide. So we prefer to have T-test. However,
Yes madam, you are.
those sample sizes that are above 30, we prefer to have Z-test. So it has been missed in MCQ 1, the number of sample size. In MCQ2, again, you have not given the full information for the correct answer, and you have not even explained why. Yes. And in MCQ2, again, please go to MCQ number 2. So in T-test and Z-test, we know that have T-test. However, if the sample size is above 30, both the T the same results, and we prefer to have Z. Right. In this, there is deficient data that is available in the STEM, so it is very difficult to save. So how would you do aloud the result? Dr. Hansa, would you please
यस
elaborate it?
मैडम. मैडम आवाज़ बहुत ज़्यादा चील आ रही है.
There are
मैडम
only
जिससे
3 minutes
सैंपल
left.
साइज
Please
आई एम.
continue with your MCQs.
Okay, I will add the sample size in the MCQs. Number 3. Our researcher want to determine whether children from divorced parents scored higher on compulsory behavior than other. He take random sample from each group separately and run an independent sample t-test. Where would be he look an independent sample t-test output to identify whether there was significant difference between the groups in the SPSS output. Levine test column no.
D.
Yes, the correct answer is Levine test column. In which of the following research questions would an independent sample t-test not be appropriate? Comparing the performance of individuals on either consumed caffeine or did not. Comparing the examination of performance of students who either done self-study or group study. Comparing mean and women's IQ on one occasion. Comparing the effect of age on study participants who have either psychological distress or not. Or comparing the effect of income on study participants who either had psychological distress or did not. The correct answer is C because we compare only the mean and women IQ in only one direction, and there is no independent variable with two categories, and independent sample t-test is performed when there is independent variable have two categories. In MCQs 5, a researcher determined the mean level of weight pre and post intervention among the same group of university students. The data were normally distributed. Which test should she use to compare her experimental condition? One way, ANOVA, two way, paired sample t-test, independent sample t.
D.
Yes, paired sample t-test because the population we want to determine the mean weight level is same. MCQ 6. Mr. Ali wants to explore the effect of gender, which is male or female, in self-esteem score. He is interested in effect of gender variable and any interaction that may exist. The most appropriate statistical test he would use is one-way ANOVA, two-way ANOVA, independent sample t-test, paired sample t-test, or z-test.
C.
Yes, correct answer is C. Mr. Bill performed the one-way ANOVA test in order to test the mean difference of self-esteem score between three or more age groups. Now he is interested in determining which particular difference between pair of means are significant. For this purpose, he would perform two-way ANOVA, independent sample t-test, pair sample t-test, z-test, or post-hoc test with ANOVA.
Post hoc test with ANOVA.
Yes, correct answer is post-hoc test because as uh, simple one-way ANOVA is tell about the mean difference of self-esteem score between three or more groups. In order for further extension in different groups of pairs, we should perform the post-hoc test in addition with ANOVA in SPSS. This is the key of MCQs and reference. And thank you.